Okay, this is 8G9, 8th grade geometry standard 9, video 1, the volume of a cylinder. And in this standard, we have to know the formulas for the volumes of cones, cylinders, and spheres. This lesson will only consist of cylinders. If I put all three of them in one, it would be way too long. So we're going to get to those other two later on as we go through this week. Here are a few terms to know. I'd like you to copy these down in your journals and define them. Okay, volume is known as the amount of space that a solid occupies. It is measured in cubic units. And if I have one example of a cubic unit, I could say inches cubed. And that would be the three dimensions of length, width, and height. And all of them would be, I guess in this case we could call it 1 inch cubed. So each edge of the cube would be measured at 1 inch apiece. It is also, in the third part here, it's to measure volume, you can imagine unit cubes filling up a solid. So no matter what the solid or prism or three-dimensional figure looks like, you are trying to put these cubes inside of it, these unit cubes. And there are layers of cubes. And we're going to have examples in class where you're going to actually be able to see a visual of this. But for the standard, they want you to know the volume of a cylinder formula, and that is V is equal to BH. Before we talk about the entire formula, I think the capital B is going to be brand new to you. So talking a little bit about the capital B, I have three figures on the board. The last one is what we're actually dealing with in this video. So just to talk about capital B, I thought it'd be important to put the other two figures in there also. The first one is a rectangular prism. And when you're dealing with the rectangular prism, they all have the same formula of BH. But the B is important because it's the base of the figure. It's what it's sitting on. So the figure that it's sitting on right down here, if I were to kind of color it in, that would be a rectangle. So capital B is known as the area of what it's sitting on. And we recall back probably last year in elementary school that the area of a rectangle is known as LW. So we could replace this B with length times width because that's the area of the base. It's the area of what it sits on. All right, the cube is the same idea, V equaling BH for the volume, except in a cube, the base of what it's sitting on isn't a rectangle, it's actually a square. That's part of the rule of a cube. So if I'm replacing the capital B, what is the area of a square? So the area of what it's sitting on would be the side times the side, also known as side to the second power, multiplied by the height of the figure. All right, now the one that we are going to really talk about today is the cylinder. And we have the same formula, BH. And what are we going to replace the capital B with? We know what the height is. It's how tall the cylinder is standing. But what can we replace this B with? Well, it's sitting on a circle. And if you recall from your formulas from before when we dealt with area of a circle was known as pi multiplied by the radius squared. So we're going to replace B with pi r squared and then finish off the formula multiplied by the height. Okay, and looking at an example of a cylinder here, we have a radius and we have the height. If we're reviewing what a radius is, if we go to the center point of the circle and we draw a line from that center point, we actually call this a ray. So we draw a ray to the edge of the cylinder. that is known as the radius. And if we were to continue this radius all the way across to the other side, when we put the radius with the other half, we would call that the diameter. So the diameter goes all the way across, and the radius is 1/2 of the diameter. That's going to be important when we get to our second example today. And the height is how tall the cylinder is, which is located right here. Okay, first example, finding the volume of the cylinder. We need to know what pi is. Okay, so there's a couple different ways that we can use pi. Maybe you've seen it as a rounded decimal of 3 14/100. Maybe you've seen on your calculator this pi button, which is more accurate than 3.14. So if we're going for accuracy, we are going to use the pi button. And then maybe you've seen on an example a fraction of 22/7. Now, if this is an improper fraction, if you think about how many times 7 goes into 22, it goes 3 and some leftover, so 3.14, etc., etc. It's not exactly pi, but it's the fraction in the world that is the closest to pi. So we use this as an estimation tool. Okay, so 3.14 is estimated, 22/7 is estimated, pretty close, and the pi button is the most accurate. Except if you go back to the terms for the day, all the way back to page 2, we are going to be writing our answers today in terms of pi. So we aren't going to be doing any of those pi actions other than leaving pi in the answer. Let's see how that looks. Okay, so if I have the volume being pi, I'm going to leave it in the answer, multiplied by the radius squared. Well, the radius is 8 centimeters. So we are going to have to square that, and then we are going to multiply by the height of the cylinder, and the height is 15 centimeters. Okay, continue on the process. Volume, we're going to keep pi in the answer. We aren't going to use the button, the fraction, or rounded 3.14. We're going to do some simplification here. 8 squared is 64. And then we have our 15. The next line, keep pi in the answer, multiply it by whatever 64 times 15 is. Let's see what that is here. 64 times 15. And that is 960. Okay, and then, to kind of write it correctly, I wouldn't leave it as pi times 960. You could technically, but I like to put pi last. So volume is equal to 960 pi, and we are using the unit of centimeters in the third dimension. We are using 3D objects, so centimeters cubed. And if you wanted to use one of these shortened versions of pi, you would have to do some rounding in your answer, and we aren't going to be doing that today. Let's just leave our answer in terms of pi. Final answer. All right, last example. Make sure you're looking at the given information, using it correctly. I have volume equaling pi multiplied by the radius squared. Well, this time they don't give us the radius. They give us the line that goes all the way across through the center. That is known as the diameter. So if the diameter is equal to 10 feet, we need to know what the radius is. Can you think about that for a second? Okay, it's 1/2 of that. So the radius is equal to 5 feet. Let's plug that into our formula. So pi multiplied by the radius squared multiplied by the height. And the height of the figure, if we were to stand this figure up, it would be 15 feet tall. All right, pi times 25 times 15. So the volume is equal to, let's see what 25 times 15 is very quickly, 375. And let's clean that up a little bit. So volume is equal to 375 pi. You can multiply that out if you would like, just to find out what the answer would really look like. Well, why don't we do that? Let's see what that answer would really look like when we're dealing in feet cubed. So 1 foot by 1 foot by 1 foot cube, how many of those are going to fit inside of this cylinder? Okay, so 375 times, let's go with the rounded 3.14, and you're going to get about 1,177.5 cubic feet inside of this cylinder here. Okay, in your journal, I'd like you to define the given terms on page 2 of the flip chart. Write a few sentences on what you learned from this video. If you have any questions, bring those questions to class and we will answer them together.